students, welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். Vari Medical Academy சார்பாக இனி வரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய faculty members லைவ் வீடியோ ஸ்ட்ரீம் உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் Vari Medical Academy சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க.
Good morning. The continuation video, the continuation class. Today we are going to discuss about the specific heats of triatomic gas molecules. That is triatomic gas specific heats. Specific heats, triatomic gas specific heats. Yeah, look at this. In this, first we want to find the energy of the gas molecules and average energy of the gas molecules, internal energy of the gas molecules. From that, Cv is equal to du by dt, internal energy by time. And from that we can get the Cp. Okay, so triatomic gas molecules energy E is equal to generally any one of kBt. Gas molecules kinetic energy is equal to half kBt. Suppose for triatomic gas molecules we need to take the degrees of freedom. This is associated with the degrees of freedom. That's why we can count the degrees of freedom also. E bar is equal to degrees of freedom for the triatomic gas molecules is 6. Okay, so it is 6 into 1 by 2 kBt. This is E bar is equal to 3 kBt. E bar is equal to 3 kBt for the triatomic gas molecules. From this, we can get the internal energy for 1 mole of gas. Internal energy of 1 mole of gas, that is U is equal to internal energy of 1 mole of gas. 1 mole of triatomic gas. 1 mole of triatomic gas is, what can you write here? U is equal to E bar into 1 mole of gas. 1 mole of gas is nothing but Avogadro number of molecules. Avogadro number of molecules is the Na. So U is equal to 3 kBt into Na. This is U is equal to 3RT. U is equal to 3 into RT because Kb is equal to, since Kb is equal to R by Na. Kb is equal to R by Na. Then we are getting U is equal to 3RT. This is internal energy of the triatomic gas molecule. Now Cv is equal to specific heat at a constant volume. Specific heat of gas at a constant volume is specific heat of gas at constant volume is Cv. Cv is equal to 1 by N into du by dt. We know this. Here N is equal to 1. That's why Cv is equal to du by dt. Cv is equal to du by dt. This is Cv is equal to d by dt of Substitute the E value, U value. This is 3RT. 3RT. Therefore, CV is equal to 3R. CV is equal to 3R. Hence, CP is equal to what can we get? CP is equal to CV plus R. So, CP is equal to 3R plus R. CP is equal to 4R. CP is equal to 4R. Then, CP by CV is equal to CP by CV is equal to CP by CV is equal to 4R by 3R. This is equal to 4 by 3 is equal to 1.33. Gamma is equal to 1.33 for triatomic gas molecules. Triatomic gas molecules, gamma value is 1.33, CP value is 4R, CV value is 3R. So, simply we can write as, here it is, average kinetic energy is 3 kBT and internal energy is 3RT. Internal energy is the 3RT. CP is the third point. CP is 4R and CV is 3R. CP by CV means gamma is 1.33. 1.33. This is the triatomic gas molecules in rigid condition. A rigid condition. Right? Yes. Next, triatomic gas molecules at non-rigid. Suppose it's a non-rigid. Then what will happen? We can. Yes. Look at this. Triatomic gas specific heats. This is the non-linear triatomic gas values. These are all the non-linear triatomic gas molecules. Triatomic gas. Non-linear triatomic gas molecules, gamma value is 1.33, CV value is 3R, CP is 4R, U is 3RT and E is equal to 3 kBT. Okay, average energy is equal to 3 kBT. This is the non-linear triatomic gas molecules. Non-linear triatomic gas molecules and linear triatomic gas molecules have the different degrees of freedom. That's why we are getting the different values. For non-linear triatomic gas molecules, degrees of freedom is 6. But linear triatomic gas molecules have the degrees of freedom is 7. Degrees of freedom is 7 for linear triatomic gas molecules. The value is 7. We can see this also. Yeah. So, from this, we are getting average energy of the molecules and internal energy of the molecules, CP values, CV values and CP by CV ratio. These are all very important. These values will be, based on these values, number of problems also there. You will try to practice the problems on this. We can do one problem also on this. After this, yes, non-linear triatomic gas, specific heat of non-linear triatomic gas. Triatomic gas. Okay, specific heats of triatomic gas. Here it is non-linear. Already non-linear finished. Now we can take linear triatomic gas. A linear triatomic gas, right? In this we have energy is equal to General energy is equal to half kBT. Gas molecules kinetic energy is half kBT. Kb is the Boltzmann constant and T is the absolute temperature. T is the absolute temperature. In triatomic gas, in linear condition, triatomic gas molecules have the 7 degrees of freedom. For linear triatomic gas molecules have the 7 degrees of freedom. According to equipartition of theorem, every degrees of freedom associated with this energy. That's why we take as average energy of the triatomic gas molecules is degrees of freedom into E. So it will become E bar is equal to 7 into 1 by 2 kBT. It's nothing but E bar is equal to 7 by 2 kBT. This is the average kinetic energy of the gas molecules when it is in linear condition, right? Next we want the internal energy of the triatomic gas molecules. Internal energy U is, what can we write? U is equal to, we know, du by dt. U is equal to du by dt. No. U is equal to E bar into Na. U is equal to E bar into Na. Average energy into 1 mole of gas. 1 mole of gas is nothing but Avogadro number of gas molecules. Avogadro number of gas molecules. That is 7 by 2 kBT into Na. Kb into Na is nothing but R. So, U is equal to 7 by 2 RT. U is equal to 7 by 2 RT. This is the internal energy. From this, we can find the Cp and Cv values, and Cp, Cv values too, we can get the Cv ratio or gamma value. That is, say this, here it is, Cp is equal to, or Cv is equal to 1 by N into du by dt. N is equal to 1. That's why I take as Cv is equal to du by dt. Cv is equal to du by dt. This is nothing but Cv is equal to d by dt of 7 by 2 RT. Its Cv is equal to 7 by 2 R just. Cv is equal to 7 by 2 R. dt by dt will become 1. Okay. Cp is equal to, Cp is nothing but Cv plus R. Otherwise, Cp minus Cv is equal to R. Cp is equal to Cv plus R. Hence, next one, Cp is equal to constant pressure, at constant pressure, specific heat of triatomic gas at constant pressure. Cp is equal to Cv plus R. This is Cp is equal to 7 by 2 R plus R. Cp is equal to 9 by 2 R. This is 9 by 2 R. Cp is equal to 9 by 2 R. Now we want the ratio of triatomic gas molecule, linear triatomic gas molecule. Okay, that is Cp by Cv. The ratio of triatomic gas molecule specific heats is Cp by Cv. Cp by Cv is equal to 9 by 2 into R by 7 by 2. 7 by 2 into R. R cancel, 2 cancel. Then we are getting 9 by 7. 9 by 7 is nothing but 7 ones are 7 ones are 7 twos are 14, 6 7 8 are 56, 4 7 6 are no problem. It's 1.2928 or 1.29. Okay, So gamma is equal to 1.28. If you take third one, 1.286. Okay, so we can also write as 1.29. Gamma is equal to specific heats of linear triatomic gas molecules. Specific heats of linear triatomic gas molecules. Energy is, so we can write first point, E is equal to 7/2 kBt. Linear condition, E is equal to, E bar is equal to 7/2 kBt. This is 7/2 kBt. And internal energy, U is equal to 7/2 RT. U is equal to 7/2 RT. Third one, specific heat at a constant volume. Specific heat at a constant volume of a triatomic gas, linear triatomic gas is CV is equal to 7/2 R. And specific heat of a triatomic, linear triatomic gas molecule at constant pressure is CP is equal to, CP is equal to 9/2 R. 9/2 R. And finally, the ratio of linear triatomic gas molecules specific heats is 1.28. 1.28. If you have 1.28 in the option, select it. Otherwise, 1.29 also take, because it will come 286. So this also write as 2.19. Okay, like that. Gamma is equal to 1.28. This is the specific heat of linear triatomic gas. Next, we are going to discuss about continuation, specific heat of polyatomic gas. Polyatomic gas. Okay, specific heat. Specific heats of polyatomic gas. Okay, see this. In this also, we are taking the kinetic energy of the molecules. Kinetic energy of the molecules E is equal to half kBt. Per molecule, kinetic energy is half kBt. Kb is the Boltzmann constant and T is the absolute temperature. In this specific heat of polyatomic gas, we need to take the average energy is nothing but degrees of freedom into energy, right? Generally we are writing like this. Here it is, E bar is equal to, in polyatomic gas we cannot find the particular degrees of freedom. Okay, for different gases have the different degrees of freedom are there. That's why we can take as F. Degrees of freedom is F into 1/2 kBt. This is the average energy. Average kinetic energy is F/2 kBt. Like this. F/2 kBt. From this, we want to take the internal energy. Internal energy is internal energy of polyatomic gas is U is equal to E bar into Na. For 1 mole of gas, E bar into Na take as U is equal to, this is F/2 kBt into Na. U is equal to, it's nothing but F/2 into kBt. Na is nothing but, kB into Na is nothing but R. So we can write as F/2 RT. This is the internal energy. internal energy of the polyatomic gas. From this, we can find the Cp and Cv values. Cv is Cv of polyatomic gas, otherwise specific heat of polyatomic gas at a constant volume is, once again, specific heat of polyatomic gas at a constant volume is Cv, that is Cv. Cv is equal to 1 by n into du by dt, 1 by n into dv by dt. This is 1 by n into du by dt. For 1 mole of gas, n is equal to 1. That's why Cv is equal to just du by dt. Okay, so substitute the u value in this equation. Then Cv is equal to du by dt of f by 2 into RT. This is Cv is equal to f by 2 into R. Cv is equal to f by 2 into R. Specific heat of a polyatomic gas at a constant volume is f by 2 R. Next we want the Cp, specific heat of polyatomic gas at constant pressure. Cp is equal to Cv plus R. This is Cp is equal to f by 2 R plus R. This is also written as Cp is equal to R into f by 2 plus 1. Otherwise, Cp is equal to 1 plus f by 2 into R. Cp is equal to 1 plus f by 2 into R. Look at this. Cp is equal to 1 plus f by 2 into R. Now we want the ratio. A ratio of Cp by Cv. This is Cp by Cv is equal to, Cp by Cv is nothing but gamma. Specific heat of polyatomic gas gamma value, or ratio of specific heats Cp by Cv is, that is Cp by Cv is equal to 1 plus f by 2 into R by f by 2 R, f by 2 into R. RR gets cancelled. Here it is. Cp by Cv is nothing but gamma. Take as f by 2 is the common. Then you will get 2 by f plus 1 by f by 2. 2 by f plus 1. Okay. So f by 2 gets cancelled, right? Then gamma is equal to 1 plus 2 by f is the ratio of polyatomic gas. What is the f here? F is the degrees of freedom of polyatomic gas. F is a degrees of freedom of polyatomic gas. Gamma is equal to 1 plus 2 by f. Okay. So, in this case, important values are energy. Energy of the polyatomic gas is f by 2. Kinetic energy of the polyatomic gas is f by 2 kBt. And internal energy of the polyatomic gas, is f by 2 RT. F by 2 RT. And specific heat at constant volume of polyatomic gas is Cv is equal to f by 2 R. And specific heat of polyatomic gas at a constant pressure Cp is equal to 1 plus f by 2 into R. And finally, the ratio of Cp by Cv, otherwise gamma value of polyatomic gas is gamma is equal to 1 plus 2 by f. This is the gamma value. So we discussed that polyatomic gas molecules, triatomic gas molecules, diatomic gas and monoatomic gas. Based on this, we will do one problem on this. Look at this. If we have a monoatomic gas and a diatomic gas is there, monoatomic gas molecules, diatomic gas molecules have the different gamma values, right? If in case the mixture of monoatomic gas and diatomic gas gamma value is, what is the average value of gamma for the mixture of monoatomic and diatomic? We will discuss that. Yes, see this, 1 mole of a simple problem, 1 mole of monoatomic gas, monoatomic gas, 1 mole of monoatomic gas is mixed with 1 mole of diatomic gas, diatomic gas, then what is the gamma value of mixture of the gas, yes, 1 mole of monoatomic gas is mixed with 1 mole of diatomic gas, then what is the gamma value? This is the gamma. What is the gamma value of mixture of gas, right? For that solution, see that, look at this, here we want the gamma is equal to Cp by Cv, we know this. Here we want Cp and Cv values, Cp of monoatomic gas values, Cv of monoatomic gas values, and here it is, the two gases are mixed, that's why we have Cv of mixture, otherwise mixture gas Cv, mixture gas Cv is, take as Cv is equal to number of moles into, for monoatomic, this is monoatomic, okay, number of moles into Cv of monoatomic plus number of moles into Cv of diatomic gas, okay, by N1 plus N2. This is mixture. Cv of mixture is equal to N1 of Cv of monoatomic. This is monoatomic, mixture of Cv of diatomic divided by N1 plus N2, where N1 is the number of moles per monoatomic gas, number of moles per diatomic gas, total number of moles. Okay, so we will get Cv mixture gas. Okay, this is N1 1 mole and Cv of monoatomic gas value we did just now. We did, what is the value of Cv? That is 3 by 2 R. Monoatomic gas value is 3 by 2 R. N2 1 mole, diatomic gas also 1 mole. Cv of diatomic gas molecule value is 5 by 2 R. Just we did this also 5 by 2 R, right? So this is 1 plus 1 mole, 1 mole of monoatomic gas, 1 mole of diatomic gas, that's why 1 plus 1. So this is equal to 3 by 2 R plus 5 by 2 R by 2. It will become CV of mixture is equal to CV of mixture is equal to 5 by 2, 3 by 2, 8 R by 2 whole by 2 means 8 R by 4, 8 R by 4. This is equal to 2 R. CV mixture is just 2 R. It's 2 R. So CP mixture, automatically we are getting CP mixture, CP of mixture and CP mixture, gas mixture is equal to CV mixture plus R. This is equal to 2R plus R is equal to 3R. Therefore, what is the ratio? Gamma is equal to CP by CV. Therefore, gamma is equal to 3R by 2R. This is gamma is equal to 2 1s are 2 1.5s 1.5. This is the gamma mixture. Gamma mixture. Yes, 1 mole of monoatomic gas is mixed with 1 mole of diatomic gas. Then what is the gamma value of mixture? Means it is 1.5. Don't take 1 mole of diatomic gas gamma value, 1 mole of gamma value of diatomic gas average. Don't take that average because we have a formula, mixture formula is there. Mixture, CV mixture is equal to N1 CV plus N1 CV1 plus N2 CV2 by N1 plus N2. Similarly, CP also we can write as N1 CP1 plus N2 CP1 by N1 plus N2. From that, we will get easily. So, 1 mole of monoatomic gas and 1 mole of diatomic gas, if we mix it, the mixture gamma value is 1.5 moles, 1.5. Okay, thank you.